Hello, grade 11 students. We're going to continue the complex number, but we're talking now in a complex plane. If you have a complex number z equal a plus ib, we know that I is root minus 1, a is the real part of z, and b the imaginary part. This complex number can be written as a point A whose coordinates are a and b, or x and y. And if you locate the point x and y, suppose x is a 3 and y is 4, you take x is abscissa 3 and ordinate is 4, and the same, for example, here another example. If you have a point whose coordinates minus 5 plus 2i, abscissa is minus 5 and y is 2. So now what we are doing, we're graphing in an xy plane where x is called the real axis and y is called the imaginary axis. So if you have a point whose coordinates are a and b, if you project on the x-axis, this will be the real part of the complex number, and this will be the imaginary part of the complex number. First of all, we're going to talk about the norm. The norm of a complex number is, you all know, square root x squared plus y squared. And we know that since z and z bar, z is a plus ib and z bar equal a minus ib. If you do the norm of both, it's the same, which is x squared plus y squared, the real part squared plus the imaginary part squared. Example 1, find the norm of the following complex numbers. So here a is 2, b is minus 3, so you square 2 and you square 9, and even if you have z bar 2 plus 3i, it's the same as we said here. And if you have this expression, you expand, you have minus 4 minus 8i, so it will be square root 16 plus square root 64. So this will be 4 root 5, the norm of example 1b. Now we're going to graph this set. What does it mean? You have a complex number z such that norm of z equal to 2. Norm of z equal to 2, it means root x squared plus y squared equal to 2. So if you square both sides, we're going to get x squared plus y squared equal to 4. X squared plus y squared equal to 4, so it's a circle whose center is 0, 0, and radius is 4. So if you see the picture, so it's a circle of center 0, 0, radius 4. However, in part B, I want norm of z less than 2. Norm of z less than 2, first of all, z equal to 2 is the circle whose center the origin and radius is 4. Because I have less only, I don't have with it equal, less or equal. So the boundaries of the circle are dot, so the boundary is not included. What part I want? I want less than 2. Less than 2, it means inside the disk of that circle. So less than 2 inside, so where I shade, get rid of, I shade outside. In part C, I want is z, norm of z bigger or equal to 3. As we said, norm of z, so x squared plus y squared bigger or equal to 9. Here I have bigger or equal, so I draw a circle whose center 0, 0, and radius is a 3. I want bigger or equal, so I want the region, the white region outside is the accepted with the boundary, so I get rid of the region inside. Now I have an absolute value, a complex number of the form x plus iy, where absolute value of x is less than 2. Absolute value of x, it means x is the real part, so x is bounded between minus 2 and 2. So I graph two lines, x is minus 2 dot, and x is 2 because I don't have equal here. Me, I want the part inside. Since I want the part inside, so I get rid of the part outside. So I shade here, the blue one here, I shaded. Similarly, y is the imaginary part, bigger or equal to 1. You know, absolute value of y bigger or equal to 1 in grade 10, it means y bigger or equal to 1 or y less or equal minus 1. So I graph y equal to 1, I graph y equal minus 1, not dot bold because I have equal. Me, I want the region outside bigger than 1 or less or equal minus 1. So where I shade here. So I'm left with these two regions. Now here the boundary is included, I put minus. Here the boundary, sorry, not included, minus, included the plus. Here the boundary is minus, since dot, here plus, here minus, and here minus. So what will be the region? So this is the solution, and here the solution. If I take the last one, z less or equal to 4, we know it's a circle whose radius is 4. I want the inner part, so where do I shade? I shade everything, the blue one here. So this part I don't want it. but the boundary is included because I have less or equal to 4, like we did in grade 10 about graphing linear equation. Then I want y absolute value less than 1, so I want the part of y between -1 and 1. This is y equal 1, this is y equal -1. I want between, so where do I shade? I shade already everything outside these two parallel lines. I'm doing it in details again for you to understand. And for x, I want absolute value of x bigger than 1. You know from grade 10, x bigger than 1 or x less than -1. This is x equal -1. This is x equal to 1. And we want bigger than 1, the solution, and less than -1. So I shade the part between that I don't want. So I'm left with this region, the white region, which is the accepted region. Here the boundary is included. I don't have a place to put a plus. Here minus, here minus, here minus. Same you do here. Minus, minus, minus. Here what? Plus. And this white region will be the solution. Now we're going to talk about something very important, which is called complex plane. Let me see time left. So in complex plane, so I will leave it for another video. So the first part we talked about the graphing. Now another video we're going to do about the polar form of a complex number.